Okay, officially this is called Factoring Day C. That means you've done A and B already, and therefore we should be up to the hardest kind of factoring of them all. But all we're really doing is adding a kind of factoring that I had on the top 20, which is going to make you be able to rock it right away. Would you please factor that if you remember how? Special kind of factoring called difference of squares. Mr. O, what'd you say? What? You have no idea? Are you serious? Oh my gosh, I'm extremely disappointed. You were up here? Now you're down here. All right. Yes? X plus 4, X minus 4 is correct. Oops, not 6, 4. Okay. X plus 4 and X minus 4. What does that mean? That means we found the square root of this, and we found the square root of that, and we put the square root of the first one here, and the square root of the second one right there. Now, how can I know that I'm right? How can I prove it? Yes? Multiply it out. So you go first would be x squared. Outside and inside are kind of cool because they cancel. They're exact opposites. And then the last, multiply to negative 16. You with me now? All right. Let's see if you're still with me on this one. Factor that one. I bet you got it. What'd you get?
I said 5x minus 4 and 5x.
You've got it. If I had to prove it, all I'd do is multiply it out, and it would come out to 25x squared minus 16. Okay, do you get that these are the square root of that? And that this one has a square root, and it's right there and there. And there's always a plus and a minus. All right, let's do one that's a little different and see if you can still hang with it. So the most common answer on this one is to go, okay, well, his square roots seem to be important, so I'm going to put an x here and an x here and a 9 here and a 9 here. And you're like, this one's different because it's got a plus in the middle. Maybe I'll make them both pluses. No, maybe I'll make them both minuses. Well, you can try it all you want with any combinations of plus minus or plus plus or minus minus, and the outside and the inside won't work. The one that's closest is to go with the plus minus again. But why doesn't this work? Because the outside and the inside cancel. Everything seems to be right except what's positive 9 times negative 9. Negative 81 is supposed to be positive 81. And so that's wrong. So this one does not factor. It's called prime. Any number that won't factor, like the number 13, you can't factor it except 1 and 13, but those aren't really factors. Anyway, the point is this is not factorable. We call it prime. So is this. It's not factorable. So don't let it bother you too much. There's some things you can't factor. So it's okay. Now, if you're like trying to solve an equation, why do we usually factor? Because it's like set equal to 0, and we're trying to be able to have two factors equal to 0, so we can say the answers are x equals 9, x equals negative 9. If you can't factor it, it just means you have to get your answer from the quadratic formula instead. And the answer would be imaginary numbers. Yes, sir? All right, why was this not right is the question. Because if I actually multiply it out, the first give me x squared. I'm good so far. My outside and my inside give me what? 18x. Do you see an 18x in that? That's the problem. Okay? And then the last do give you positive 81. It's just that that pesky outside-inside gives you an 18x that isn't in the problem. So that one does not factor. Why? Because it's supposed to be called a difference of squares. Is a plus sign a difference? No. So let's try one more. This one will factor, I promise. 81x squared minus 36. Perfect square, and a minus. It's a difference of squares. So it will factor. Mr. T, got it already?
Yeah.
What you got?
9x plus
If you had to prove it, what would you do? Multiply it out. And you'd use FOIL probably to do that. All right, cool. Here's one that really annoys people. That can be factored. If you're like way thinking deep right now, you're overthinking it. Remember that whole, the first thing you should do is look and see if there's something in both of them. Is there anything that's in both of them? Yeah, an x. X comes out, and what do I have left? When I take an x out of this one, what do I have? 6x. When I take an x out of that one, I have to leave a placeholder, so plus 1. Really common mistake people think is, well, when you take the x out, isn't there nothing left? Yeah, but if I put a 0 here, when I multiply this back out, it won't work. So there has to be a 1 there to hold the place. And then when you go x times the 1, you'll get the x that you want. All right, so let's do another one like that. 6x squared plus 4x. That factors. It's not a normal kind, but it factors. Now I want you to set it equal to 0 and give me the answers. If you factored it, it should be easy peasy. Turn it my way when you've got it, and I'll tell you if you factored it and you got the right answers. Yes, good job. You factored it, and I'll get the answers also. Reduce that, and then ask me. Ooh, Mr. Fancy writing it in point form. Okay, good. Reduce that, and then ask me. Yep. Yep. Good job. Yep. You got one of them, but you lost one. You got one of them, but you lost one. Something went wrong with your fraction. Yup. Yup. Maybe it's because you factored wrong, Mr. A. Yup. Good job. Yup. 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 It's kind of like popcorn. The beginning is only a couple pops, and then all of a sudden they all pop at once. And then there's a few that never pop. All right, so let me show you. What happens? Both those things have an x in them, but they also both have a 2 in them. How many of you knew to take out a 2x? Raise your hand if you did. Okay, good. And then what's left? Well, really, I'm dividing this by 2x. That's what's really happening. And what's left when I do that is 3x. What's left when I do that? Plus 2. And how can I know I'm right? I can FOIL it back out again, and that would be 6x squared, and that would be 4x, and that's what I wanted. And this all equals 0, so then I have it all set up to just get two answers. This answer, which is 3x plus 2 equals 0, is 3x equals negative 2, so x equals negative 2/3. And over here, 2x equals 0, and x equals 0. X equals 0, x equals negative 2/3. Any questions? Okay. That's the stuff, that's the new stuff for today. That's called difference of squares. Just make sure you don't ever try to factor one and get sucked into thinking you have an answer of x plus 9 and x minus 9 and this kind, because it's not a what? Not a difference of squares. It's a sum of squares, and you can't do it the same way. If you want to see if you can stretch your brain to its breaking point, you can do it this way. X and plus and minus 9i. You got it. because then firsts make x squared, right? Outside and inside cancel just like I want. And what happens when you take 9i and negative 9i? You get negative 81i squared. And what's negative 81i squared? Do you remember that I squared is actually equal to negative 1? And therefore it's negative 81 times negative 1, which makes positive 81, which makes it actually work. But don't worry, we're not going to put that on the test. I knew some of your brains would explode at that moment. All right. But if it didn't explode, then you'd know the answer to that. How many think you got it? Raise your hand if you think you got it. Looks like 7 people think they have it. This would be x plus 2, x minus 2 would be the normal answer, but this is a plus in here. So it can't work like normal, so you go I. There we go. X plus 2i, x minus 2i. All right, that was above and beyond. Didn't need to know that. Okay, so now your homework for today is got some review in it. I want to talk through some review here. Let's say that I had a parabola that touched here at -1 and here at 13. I'd like you to tell me where its axis of symmetry would be. That line that runs down the middle, I kind of made it quick and deformed on purpose because I don't want it to be, I want you to have to figure out mathematically where is the middle, not just like looking at the picture, where's the middle. You got it? Okay, don't say it yet. If you have the answer, make sure your answer isn't just a number. Because if you think it's just a number, you're doing it wrong. The axis of symmetry is an equation. Yes, 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 yes. There, yes, yes. It needs to be an equation. You're really close. Yes. You're off by 1. Yep, it's because one of the numbers was negative and you did something wrong because of that. Yes, yes. Nope, you're off by 2. Yes, 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 yes. Here's what happens. Yes. Yes, you should average these two numbers, but people make a mistake. They go 13 plus 1 makes 14. Now, when you're averaging two numbers, you add them together. 13 plus -1 makes 12, and then you divide by 2 makes 6. I can see why you might think it was 7, because you might think, oh, I'm going to go, the distance between them is 14, and so don't do it that way. You average them by adding them together and then divide by 2, 6. So if I say 6 alone, I will get it wrong, because remember, on this entire test, they're all supposed to be like x equals 6 or y equals 6 or a parenthesis around the 6 or whatever to make it a point, like this or something. But just a 6 would be bad. In this case, we wanted x equals 6 is the axis of symmetry, the line that runs right down the middle of that parabola. Then, last but not least, if I tell you there's no stretch factor, you should be able to tell me where its vertex is. You know it's somewhere on this line, so you know x equals 6 is involved somehow. You better figure out what the equation is. Remember, I said there's no stretch factor. So you should be able to write the equation for it right now. Once you know the equation and you know the axis of symmetry, the vertex is easy. It's not super easy, or I wouldn't be talking to you about it. I'm reviewing it because it's got some challenge to it. Let me just check for a second here. Yes, nice job, Mr. B. You got your equation. Oh, wait, there's your answer?
Yeah.
All right, yes, good job. Nope, thanks for trying. Yup, you got it. Yup, you got it. That's one number, remember?
Oh, yeah.
Yes. Don't give me a single number. You got the first part right, second part wrong. I can't tell if it was your equation or what. That first number is not a 0. All right, and I know there's a lot of people don't know what to do, so I'll tell you. Good. All right, so here's what you should be thinking. What's the equation? The equation comes from this, and it's y equals, I said there was no stretch factor, so I can just go like this. And then what two things? X plus 1 for this, and x minus 13 for that. Then, this x equals 6 I said was important. It's because you can stick a 6 in right here and right here. And that'll tell you what y is. 6 plus 1 is 7, and 6 minus 13 is negative 7. You notice they've always come out opposites? Makes sense. Always, it's 7 and negative 7, or if it was 3, it'd be negative 3. So anyway, final answer, negative 49. Why can't I just write negative 49? Because I need a point. The vertex is a point, something, comma, something, and negative 49 is the y of it, and the x of it was this. So 6, comma, negative 49. All right, that was a tough one, I know. I'm going to give you another one that's similar. See if you can do this one all by yourself. This is at 8. This is at 12. And the axis, or the origin's like way over here somewhere. So if this is a parabola without a stretch factor, what's its vertex? I'll pause for a second while you try that. Should record this. Okay, so I'm finding the axis of symmetry down the middle. I'm adding up these two numbers and dividing by 2 to find what goes right down the middle of them. That adds up to 20. Divided by 2 is 10. X equals 10 is really important. And I now know that my vertex down here has got a point 10, comma, something. And how do I figure out the other part, the something? That comes from the equation. And the equation is y equals, since I said there was no stretch factor, x minus 8 and x minus 12. Then I just stick the 10 in here and here. That x equals 10 just drops into the equation twice. So 10 minus 8 is 2, and 10 minus the 12 is negative 2. Always come on opposites. Negative 4. 10 comma negative 4. Raise your hand if you had that one right. Almost everybody. Nice job. Okay, this one's a little more obscure. Now what's the vertex? I'll pause for a second while you try that one. If you have trouble, make a little sketch. Did you figure out that it's 2 and negative 6, and the line that runs between them is there, and therefore I can still average. Remember, I'm averaging negative 6 and positive 2. Okay, so I add those together, I get negative 4. The average of them is negative 2. Negative 2 is your axis of symmetry. Raise your hand if you had that right. Awesome. And then, what do I do from there? Tell me. Who can explain it to me? Yes, sir. Yep. You put the negative 2 into the x, just like that. Nice. That becomes positive 4. That becomes negative 4. Have you noticed that pattern? Positive 4, negative 4. And so then that multiplies to negative 16 times 3. Ooh, nasty. So 3 times negative 16. Hopefully you know how to multiply. Okay, 6 times 3 is 18. 3 times 1 is 3 plus 1 is 4. 48, and it's negative. So my answer is negative 48. And if you wrote this, I'd cry a little bit and mark it wrong. Because what? It's actually got to be a what? A point. What is the point we wanted? Negative 2, comma negative 48. Now that is the right answer. Raise your hand if you had that same thing. A lot of you did. Okay, cool. All right. Now, I want to do one more kind where you got to multiply out because there's a lot of general form. I mean, anything can be turned into general form. You can take factored form, make it general form. You take vertex form, make it general form. Okay. So, hold on one second. I'm going to get you a good problem for this. Okay, this is factored form. I want you to tell me general form. So generally just multiply it out. I want you to tell me vertex form because you'll be able to figure out what the vertex is on it. Make a little picture. Picture's worth 1,000 words. So find me general form and vertex form. And then, of course, from that, you'll know the vertex really easily. And I'd also like to know the y-intercept. And I taught you a saying about that. It should pop into your head right away. The y-intercept is where something. All right. This is a typical R3. You have to answer all those parts. This is kind of actually a hard R3, but you'd have to answer all these parts to be able to get this tough question right on the test. All right, I'll pause for a second while you try that. Here we go. General form, generally you just have to multiply it out. X squared, outside, inside, minus 16x lasts, plus 60. Did I do that right? All right. Oh, I just lost 5%. Y equals. How many of you, be honest, forgot the y equals? Okay. I'm only doing that to you now because, you know, you aren't taking the test right now. I can remind you now before it's too late. Okay, the vertex form. To make this vertex form, I got to know where the vertex is. All right, so I got to do this little thing with the 6 and the 10 and then say, okay, here's a 6, here's a 10. The line runs right down the middle. That would be at x equals 8. And then I just have to put that axis of symmetry 8 in here. 8 goes in here, 8 goes in here. And that makes what? 2, and that makes what? Negative 2, and 2 times negative 2 makes? Negative 4. So the vertex would be at 8 comma negative 4. All right. Your homework for today is in the normal spot, and it is very easy. Enjoy. Have a good day. I'll finish this one up for those of you at home. The vertex form would then be y equals x, and then minus 8 squared minus 4. And then the y-intercept is where x equals 0. I'd put a 0 here and a 0 here, and I would have positive 60. So the y-intercept is 0 comma 60, or y would be 60. Yeah, and it's right there. That would have been a lot faster. Very good. Okay. Okay, and that's all I have for the video for today.